Okay, so this video is about rectangular hyperbola, right? So let's see the basic shape of the rectangular hyperbola. The most basic form of rectangular hyperbola is y equals 1 over x. All right. So we could see from the table, if you see that x becomes bigger and bigger, y becomes smaller, and if your x becomes more negative, actually y approaches 0 as well. Okay, so here comes the curve, right? For the curve, there are one very distinct feature is that there are two asymptotes. One is the horizontal asymptote. In this graph, okay, the horizontal asymptote would be the x-axis. So the x-axis, or you might say y equal to 0. And for the vertical asymptote, it should be this one. So that's y-axis, and you could say x equals to 0. Okay, so what do we mean by asymptote? Asymptote means, for the horizontal asymptote, it means when x tends to infinity or negative infinity, the value of y, the curve, will tend to that horizontal asymptote. Okay, so in this graph, you will see when x tends to very big, so y tends to 0. Let's say y tends to 0. Okay, while y just equals 0. Also, when x tends to very negative, y also tends to 0. On the other hand, for the vertical asymptote, we see here, the vertical asymptote is around x equals 0. Okay, so you will see when x tends to 0, y either tends to positive infinity or y tends to negative infinity. That just means when x approaches 0, you see the graph rises sharply when it's on the right hand side, the positive side of x, or it declines very sharply on the negative side of x-axis. So both means the feature of that vertical asymptote is like you need to see something when you have that x approaches to that value, y either tends to positive infinity or negative infinity. Okay, so in the examination, you might see some form like this, which is the general form. Okay, for this general form, you will see there are two parts. One part is in the denominator of that function, that's x minus b. Okay, so that part will determine where is the vertical asymptote, and the other part is plus c. Okay, so this part will determine the horizontal asymptote. Okay, so how could we know where is the vertical asymptote and the horizontal asymptote? Okay, let's have a look for this one. Okay, so you see there are two asymptotes. So let's first focus on the horizontal asymptote. This one, right? The horizontal asymptote. So for the horizontal asymptote, you see this time is along the line y equals 3. Why is y equal to 3? Okay, let's have a look at the function. So the function here is y equals 1 over x minus 1 plus 3. Okay, so let's consider when x becomes very big, what happens? When x becomes very big, then y will equals 3. Why? Because when x becomes very big, 1 over x minus 1 will tend to be 0. So that's the logic. Okay, so our logic is like this. For this function, okay, if we put x becomes very big, so 1 over x minus 1 will become 0. That makes sense? Because you see there's 1 over a number. When that number becomes very big, then 1 over x minus 1 equals 0. Okay, so if y1 minus 1 over x minus 1 equals 0, so what happened to y? So y equals 3. So therefore, y equals 3 is the horizontal asymptote. Okay, so let's write horizontal asymptote here. Okay, so let's just highlight this. So this is our horizontal asymptote. So how about the vertical asymptote? This case, the vertical asymptote is indicated by this green line. Okay, so this vertical asymptote is what we call x plus 1, as you can see. But how can we know is x equals 1? Okay, so this is something to do with that denominator x minus 1. Okay, right? So how about our what's the logic behind this? Okay, so for vertical asymptote, what happens is you need to find something which will make that x minus 1 0. Because when x minus 1 0, the y becomes undefined. Okay, so let's say x minus 1 equals 0. That will make y undefined, right? So possibly I should write y is undefined when x minus 1 equals 0. Okay, so that means x equals 1. Okay, so that's why x equals 1 is our vertical asymptote. Okay, so you see that? How can we find horizontal asymptote? You just consider when x tends to a very big number, consider what y will become. Okay, how to find a vertical asymptote? It is when you put that denominator 0. When denominator 0, it becomes undefined. So on the graph, when it is undefined, you can see the graph will approach infinity or negative infinity on either side of the vertical asymptote. Okay, so that's it. So that's the thing we need to know, how to find the horizontal asymptote and vertical asymptote. Okay, so here we are going to do some exercise on how to find horizontal asymptote and vertical asymptote. Okay, for horizontal asymptote, how can we find the horizontal asymptote? Okay, let's say for the horizontal asymptote, we need to think about what happens when x tends to infinity. Okay, so let's say when x tends to infinity. Okay, so how about y? Because y is 2 over x, so when x becomes very big, of course, y will become 0. Okay, so that means y equals 0 is the horizontal asymptote. Okay. Let's say how could we find the vertical asymptote? Vertical asymptote happens when y is undefined. So we say when y is undefined. Okay, so the denominator or fraction must be 0. So we put x equals 0. Okay, so x equals 0 would be the vertical asymptote. Okay, that's it. Alright, so let's do the next one. Okay, let's see this one. Okay, for this one, okay, let's find the horizontal asymptote first. For horizontal asymptote, we will consider when x tends to infinity, and this time we'll see that 3 over x becomes 0. So y will becomes 0 plus 4, so y equals 4, alright? So you will say y equals 4 is the horizontal asymptote. Okay, so how to find the vertical asymptote? For vertical asymptote, you need to make that y undefined. So when y is undefined, then you have to make that x equals 0. Okay, because the denominator must be 0. Okay, so this time x equals 0 is the vertical asymptote. Alright, so that's it. Okay, so let's move on to the next one. Okay, I need to just save some time for me to rewrite all the thing. Okay, for horizontal asymptote, we need to consider when x tends to infinity. When x becomes very big, what happens? So, of course, y becomes 0 this time because of minus 2 divided by a very big number, minus 1. Okay, so that must be 0. So y, okay, equals, possibly I should write this one, equals 0. Therefore, y equals 0. So y equals 0 is horizontal asymptote. Is that okay? How about the vertical asymptote? For vertical asymptote, you have to make that y undefined. So when y is undefined, okay, so x minus 1 must be 0. Okay, therefore x equals 1 is the vertical asymptote. Okay. Sorry. So this, cancel this. Okay, for this question is y equals 5 over x plus 4 minus 6. Okay, so let's do it again. So let's think for horizontal asymptote, you need to consider when x tends to very big. Okay, so that 5 over x plus 4 equals 0. Okay, and if that's 5 over x plus 4 equals 0, then what happens to that y? Okay, so y would be 0 minus 6. So basically y equals minus 6, and that y equals minus 6 will be the horizontal asymptote in this case. How about the vertical asymptote? For the vertical asymptote, you have to make that y undefined. Okay, when y is undefined, x plus 4 equals 0. Okay, so that means x should be minus 4. Therefore, x equals minus 4 is the vertical asymptote. All good? Okay, so here's there are two. So when I give you some time, you try to do this by yourself, and we'll check the answer. Okay? Alright, so for the first one, again, when x tends to infinity, minus 2 over x minus 3 equals 0. So y becomes 8. So y equals 8 is the horizontal asymptote. Okay, for the vertical asymptote, you need to make that y undefined. So that means you have to make x minus 3 equals 0. So x equals to 3. And so x equals to 3 is the vertical asymptote. And for the last one, okay, for this one, that would be for the horizontal asymptote, you just make sure that the fraction part becomes 0 by considering x tends to infinity and y equals to 3. So y equals 3 is the horizontal asymptote. For vertical asymptote, you have to make that 2x minus 1 0. So in this case, x equals 1/2. Okay, so that's it. Okay, so let's see another type of question. They will ask you to sketch the graph. Okay, how could we sketch the graph? Alright, to sketch a graph, you need how many points? You need at least 3 things. Okay, let's say you need to find the horizontal asymptote, vertical asymptote, and possibly, if possible, you need to find one extra point, which you possibly would be the y-intercept or x-intercept. Okay, so let's see how could we draw this graph. Okay. Let's say for this graph, to sketch the graph, you need to find the horizontal asymptote. Okay, to find the horizontal asymptote, you need to consider when x tends to infinity, then we have this one equal to 0. So therefore y equals, okay, so y equals minus 3 is the horizontal asymptote. Is the horizontal Okay, that means if I'm going to draw a graph, okay, I need to draw a line which is y equals minus 3. Okay, so y equals minus 3 is over here. Okay, so so that's y equals -3. That's the horizontal asymptote. Okay, so the other one is how to find the vertical asymptote. Okay, to find the vertical asymptote, you need to consider when y is undefined. When y is undefined, so you can't find y, so the denominator of that x plus 1 must be 0. You make x plus 1 equal 0. Therefore, x equals -1. Okay, so we know x equals -1 is the vertical Okay, so the last thing you would like to do is to find one extra point. Okay, but before we are going to find extra point, let me show you why we need that extra point. Okay, you have a horizontal asymptote. Now I'm going to draw another one, which is a vertical asymptote around x equals -1. So here would be okay, the x equals -1. Okay, let's say this point is -1. Okay, so how could we sketch that curve? Right, so you see when we have the curve, it's in the shape of like this, but actually there could be two possibilities. If you want to draw something which is approach both asymptotes, possibly you could draw things like this. It's just like an example. It doesn't mean it must be right. Okay, so you'll be one of like this, or you might draw another one like this. Okay, so that's one possibility, but you might also have another one like this. Okay, sorry, I try to okay, like this. Okay, so basically there are two possibilities given the two asymptotes. Okay, so you need an extra point to determine what kind of shapes you are going to use in the end. Okay, so for this one, because we could put x equals 0, so possibly it would be easier for us to find the y-intercept. Okay, so let's use the y-intercept. Okay. Alright, so let's use the y-intercept. Okay, for this one, to find the y-intercept. How could we find the y-intercept? We put x equals 0. So y would be 0 plus 1 minus 3. Okay, so it would be -1. Okay, so y equals -1 would be our y-intercept. So where is that point? So that point should be around here. So that's y equals -1. Okay, so basically if you want to have a rectangular shape, a rectangular hyperbola, and you want to approach two asymptotes, and also you need to pass through that -1 as the y-intercept, then you have to draw the curve like this, right? Have to draw a curve like this. Okay, otherwise it's impossible for you to draw the curve. Okay, right, so let me draw it properly. Okay, oh sorry, I used a different. Okay, so possibly there'll be one way to draw it, and there's another way. So you see, okay, so the orange curve will be the answer, right? So you have to check whether the curve you draw approaches two asymptotes and also pass through the extra point you found. That means to sketch a graph for rectangular hyperbola, you need to find out horizontal asymptote, vertical asymptote, and one extra point. So that extra point possibly be easier if you find y-intercept. Okay, so let's see another one. So this is another curve, suppose. Okay, so for this curve, again, we're going to find the a horizontal asymptote first. Okay, so let's say for horizontal asymptote, we're going to put x tends to infinity, y will be 0. Okay, sorry. Need to be more consistent with my presentation. So when x tends to infinity, that's minus 2 divided by x minus 1 equals 0. So y equals 0. So that's horizontal asymptote. Okay? And how could we find the vertical asymptote? For the vertical asymptote, how could we do it? You need to consider when y is, and so x minus 1 must be 0. So x equal to 1. Okay. Alright, so now you have horizontal asymptote and also you have vertical asymptote. How can we do it now? No, you need extra point. So let's find, in this case, we could find y-intercept. Okay, when x equals 0, you got y equals minus 2, 0 minus 1. So that would be 2. Okay. So how could we sketch the curve? Alright, so I'm running out a little bit of space. Okay, let's draw a smaller curve then. Okay, let's first have a look. The horizontal asymptote is y equals 0. That means it should be just the x-axis. Okay, will be the x-axis, will be the asymptote. Okay, and also the vertical asymptote happens when x equal to 1. So let's draw it. 1. Okay. So it's something like this. So it's 1. Okay. And how about the y-intercept, which is y equals 2. Okay. So here's the point. Okay. So imagine you need to sketch a hyperbola approach to asymptotes and also pass through that blue point. Okay, let me amplify this. Right, how could we do this? Of course, you could always. Okay, so let's say if you try to draw a curve, suppose if you try to draw a curve like this, what's the problem? Okay, if you still can't see it, let me draw the other part of the curve. It will be like this. Okay, so the problem is if you draw the curve like this, you can't pass through that blue point. Okay, so that means you should do the other way. Okay, so by doing so, you can pass through that blue point too, and also your approaches to asymptotes as well. Okay, all right. Okay, so that shows how could we sketch the curve. Right. So the other type of the question would be, how could we determine the rule by given the condition? Okay, you need to find the rule. Okay, suppose they give you the rule of the form y equals a over x minus h plus k, and they give you vertical asymptote, horizontal asymptote, and pass through and the point. Okay, how could we find this? Remember that for horizontal asymptote, okay, we need to consider when x tends to infinity. For vertical asymptote, you need to consider how to make that y undefined. Okay, so let's find using the horizontal asymptote first. Okay. Okay, so this time we need to do things in a reverse manner. So in the previous examples, we don't know where is the horizontal asymptote. Okay, so but now you know the horizontal asymptote is y equals minus 4. So that means you could say, since we know the horizontal asymptote is y equals minus 4. So that means when x tends to infinity, y equals minus 4. Okay, for the equation, okay, when x tends to infinity, what happens? When x tends to infinity, we will have a over x minus h must be 0, because x becomes very big. So no matter what values are for a and h, okay, the whole fraction will still become 0 because x tends to infinity. So in this case, we will have y equals 0 plus k. Okay, so that means y equals k. Okay, but since we've already known that y equals minus 4 as the horizontal asymptote, therefore the conclusion is k equals minus 4. Okay, so that will be the logic for the k, how to find the k. Okay, so let's see how could we use the vertical asymptote. Okay, so since vertical asymptote is x equal to 2, therefore y is undefined when x equal to 2. Okay, alright, but for, okay, again we use this one. We going back to this equation. For this one, when y is undefined, what happened? Okay, x minus h must be 0. Okay, so that means x equals h, but we know x equals 2. Okay, so h equals 2. Okay, so now you've already got h and k, but we still need to find a. How could we find a? Okay, so now we will have y equals a x minus h, minus 2 minus 4, because k equals minus 4. Okay, so we still need to find a. How could we find a? to find a, you need to use the last point 0, 4. So it's given that it passes through 0, 4. So we're going to find a. How could we do that? When x equals 0, y equals 4, right? So that's the given condition. So you will make, alright, so let's say y equal to 4, a over 0 minus 2 minus 4, and that will be 8 minus 2, so a will be minus 16. Okay, so after you get that, you could just write the rule. Okay, you got both a, h, and k. Alright. Okay, so the other type of question would be they give you the graph, which is very similar to example 4. They give you the description, but now they give you the graph. How could you find the hyperbola? Okay, so to find the hyperbola, again, you need to find the horizontal asymptote and vertical asymptote, and also the extra point. Okay, so let's for this one, let's let the general form, okay, which is a equals x minus h plus, or you might use b. Okay, so we use b before, possibly it should be more consistent. Okay, so by using that, okay, so when you observe the curve, you see that's where is the horizontal asymptote from the graph. Okay, the horizontal asymptote is x equals, y equals minus 2. So we are going to use these facts for us. Okay, so how can we use this? We know when the horizontal asymptote is y equals minus 2, that means when x tends to infinity, you will see y equals to minus 2. Okay, but for a form when x tends to infinity, you will see a over x minus b equals 0. Okay, so that means you will have minus 2 equals 0 plus c. Okay, so that means c equals to minus 2. Okay, so that's how we find the value of c. Okay, could we use that vertical asymptote? Okay, the vertical asymptote is x equals 1. Okay, so how can we use this? We use this, we say when y is undefined, x must be equals 1. But from the form, when y is undefined, okay, you should have x minus b equals 0. So that means because x is 1, so y minus b is 0. Okay, so b equals 1. So you could find b by using this. Right, so now you've got two parameters, b and c. You still need to find a. To find a, you need extra point. So that will be the extra point. 3 minus 3 is given. Okay, so let's say y equals Alright, so you've got this one. How could we do it? So because the point is 3 minus 3, okay, so just substitute the values into the graph. Okay, so possibly I should have some remark for that. Okay, since when x equal to 3, y equals minus 3, so we put these values and you put that minus 2 to the other side, becomes minus 1, and a over 2, so a equals minus 2. Right, so the equation would be the rule is y equals minus 2, x minus 1 minus 2. Okay, alright, that's how we do it. Okay, so let's try another one. Okay, for this one. Okay, so let's do some partition first. Okay, for this one again, you see you need to let that y equals ax minus b plus c. Okay. Okay, so for the graph, the horizontal asymptote is y equals 2. Alright, so that means when x tends to infinity, you need to have y equals 2, right? But from the original form, you will see when x tends to infinity, a over x minus b will be 0, so that will be 2 equals 0 plus c. Okay, so this time c equals 2. Okay. Then, how can we find the vertical asymptote? From the graph, you could see the vertical asymptote is x equals 2. Okay, so horizontal asymptote and vertical asymptote both are related to 2. Okay, so that means when y is undefined, x equals 2. Okay, so how could y undefined? That happens when x minus b equals 0. Okay, so that means 2 minus b equals, x minus b equals 0. And so that means 2 minus b equals 0 and b over 2. Alright, so after all this, you still need to find a. So let's say now you will have a equation, right? So since, let's say, this point 3, is on the curve, when x equal to 3, y equal to 3, so you will have 3 over a over 3 minus 2 plus 2. Okay, solving these, you will find a equals 1. Alright, so in the end, the equation would be y equals 2 over x minus 2 plus 2. That's it. Okay, hope you find this video useful. Alright, if you have any questions or comment, please leave your message on the YouTube. Thank you for watching.